Hello everyone, we are Team 25 from the SC of 502 course at Arizona State University. Over the past few months, we have been working on building a new programming language called Mint, a lightweight, readable, and beginner-friendly language designed from scratch using Java and ANTLR. Our team includes myself, Vishnu Kumar Adhilakshmi Kalidas, along with Kiran Venkatachalam, Monisha Krishnamurthy, and Rahul Ravindra Reddy. So why did we build Mint? The idea was to create a small language that's expressive and powerful enough for educational use, yet intuitive for people who are just getting started with programming. We were also very focused on understanding how interpreters work, so we wanted full control over grammar, parsing, and runtime evaluation. Mint uses readable keywords like mintif, mint for, mint while, say, and say line, replacing traditional syntax with something that's easier to grasp. On the tooling side, we chose Antler 4.113.2 for parser generation, Java for building the runtime, and VS Code for collaborative development. Our GitHub repository is fully set up with grammar files, evaluator, sample programs, and instructions. And since everything is in Java, Mint runs seamlessly on Windows, Mac OS, and Linux. From grammar design to parse tree visualization and final execution, we have built Mint end to end. From here, Monisha will take over.
Yeah, thanks, Vishnu. So now let's talk about the backbone of any language, that is its grammar. We began by writing the grammar in ANTLR using the G4 format. We carefully designed lexer rules for keywords like mint if, mint else, mint while, and mint for, as well as for symbols, identifiers, numbers, booleans, and strings. And then came the parser rules, which follow operator precedence, starting from ternary expressions at the top and working down through logical, equality, comparison, arithmetic, and finally primary expressions. We support four data types in Mint, that is the Mint int, Mint float, Mint bool, and Mint string. All of them are strictly type checked in our evaluator. We also added support for ternary expressions using the question mark followed by semicolon operator, which helps express compact logic. And to test everything, we used Antler's test trick tool, both from the terminal and from the graphical user interface. This helped us verify the correctness of tokens and parse tree generation, and also verify the behavior of each sample program before moving forward. And our grammar supports variable declarations, assignments, print statements, loops, and conditions, and is now stable and is also extensible for future features. Rahul can take over from here.
Yeah, thank you, Monisha. So once we are done with the parser and the grammar rules, we started implementing the Mint evaluator and the execution architecture. So with all our grammar and the parsers rules in place, we moved on building the interpreter. That's where our Mint evaluator class comes in. The evaluator is written in Java and uses the visitor pattern to walk through the parse tree generated by the antler. For each rule, like the declarations, assignments, and expressions or loops, we defined corresponding visitor methods to evaluate each of them. So our different interpreter handles are like we have many of them. So I'll be explaining few. So one of our rule is variable declaration and run type information. Also, we have arithmetic operations with type promotion, logical and comparison expressions, print statement with say, conditional branches with mint if, mint else, and nested blocks, loops using mint while, mint for, with support for mint break and mint continue. Along with one thing we are proud of is a strict type validation we implemented. If you assign a string to a variable declared as a mint int, the evaluator will throw a runtime error. Also, we supported string concatenation, even added checks for division by zero, logical short circuiting, and the nested expressions. Overall, the evaluator brings the language to life. You write a .mint file, run it through an interpreter, and see real-time output, just like a real-time scripting language. So now on, Kiran will take over the source code and how it is executed.
Okay, thank you, Rahul. So in terms of the sample programs, we created a total of 10 sample programs, and each one is designed to test a specific concept. So those would be the arithmetic and logic, the control structures, the type declarations and runtime validation, loops and conditionals, and then ternary expressions. So each of these main programs run successfully through our interpreter, displays the expected output, and then generates a valid parse tree. So we structured these samples to be intuitive, well commented, and useful for testing. They also develop as a mini test suite for anyone extending mini Mint in the future. So this is how the tokens and the output generally look. So the first slide that I'm showing right now is the tokens for the sample one dot mint, which we run from here. And then the second would be the parse tree. And then this would be the execution of the sample one dot mint. So I'll quickly run through a demo also at the end of this presentation. So in terms of the future scope, we're considering adding functions and scoping rules, supporting lists and arrays, building a simple standard library, and then creating a web-based ID or a playground for Mint. So we also designed and contributed to a presentation PDF, that the one that you're seeing right now, and the recorded demonstration video, all of us together. So which will be available on our GitHub repository shortly. So overall, we are actually very happy with the progress that we have made. So we started from grammar design to evaluator, and then the interpreter, all while learning the internals of language parsing and execution. So this has been a happy ride. Thank you, team. So let me quickly jump on to the demo and show how things work there. Okay. Okay. So I hope the ID is also visible right now.
Yeah.
Yeah. Okay. So let me start from the Git itself. So if I do a Git status, so this is our repo that is taken from the remote. So this is the branch main. And then if you see this, it says everything's up to date already. So let's quickly, let me show you how it works. So with the project structure, so we have the build folder, which contains all the class files of the lecture and parser. So we have the runtime folder inside the build, which is also, the class files of evaluator and the main class. So we have a data folder that contains all the 10 sample programs that we have collaboratively designed. And then there's a doc folder which contains the required documents for the deliverables. And then the source folder, which is the most important. So we have the gen file. So gen folder, which contains the lecture and parsers source code. So all of them are Java files. And then if you see the runtime, it has two files, which is the evaluator, which contains all the overridden methods that we have. And then one is the Java file. So the main file. All right. Now, this is the most important part. So we have the main.g4. So this is our grammar file. All the rules, all the parsing rules, everything is inside. Now, let me take a sample program and show it to you how it is executing step by step. Okay, so let me open the README file. So this contains all the important information, how we have come through this journey. We have checkpoints defined, 1, 2, 3, and 4. And then the tools that we are using, and also the structure summary. And then finally, if you see, this is how you're going to run all the programs and see how the output looks like. Okay, so here, as I told you, let me take in one of the sample file, the sample1.mint. Okay, so this is the one that we are going to run right now. So since this structure already has all the important class files, I'm just going to right away execute the file. All right. Okay, so if you want to view the tokens, let me do that. So this is the sample1.mint. I'm going to try to execute the tokens. Okay, and this is the list that we see right here, right? Okay, and then we have the end of file. Let me clear this. We go to the next one to generate the tree. Okay, so this is how the parse tree looks, pretty big, but then this is the next thing that we wanted to demonstrate. Okay, Now, if you want to view the same thing in terms of a GUI, this is how it gets generated, right? Yes. Okay. So this is good. And then finally, to execute the sample programs, let me take in this example, and then I put it here. And then on the top, you see that this thing, right? This is the output. This is the execution output. So if I go into the program, I see that x is 10, the y is 5, right? So the first thing that I'm trying to do is x plus 5, and I should get 15. X minus 5, I should get 5. X into y, I should get 50, and so on. So this is how we are trying to, simply play with all the operations, logical and arithmetic. So this is how it's done. And then the tree that you see here, we have done that for, reference, just in case we don't run cross into errors. So that's the thing. And I think this is it from my side. And we are good to go. Thank you, team.
Thank you.
Thank you.